This is an IETF meeting, so it's being, the note well applies, it's being recorded, and if you know anything about any IPR related to this, either talk to us about it or don't say anything at all. You've all, hopefully all by now seen the link to the minutes. Please fill in your names there. This is the first time I'm doing this in a role as working group co-chair, moderating this. One administrative point I'd like to bring up is to congratulate Francesca on being the next area director for us, taking over from Barry. So thanks, Barry, for doing this for the time you've done it, and welcome, Francesca, and congratulations in your role, which unfortunately also means that I will need someone else to join me in chairing this. Francesca is nice enough to spend some time here until kind of things are settled in. But yeah, we're looking for someone to join us here. The first thing on the agenda is working group document status. This should be rather brief since there is now a -04 of OID uploaded by Carsten, I think, today. The only thing that's keeping this in the working group, given that it has passed the working group last call, is the IPR statement from the other author. Once this is good, then Francesca and I can complete the Shepherd review and basically handing over the thing to me, because otherwise Francesca will have to do gymnastics in case she would miss out on pushing on letting this go forward. The other topics for today are working implementation survey. This is something that Michael can then say a bit about it. Basically a follow-up from the last meeting. And the other topic that's not on the agenda yet, but came in on short notice, is PAC CBOR, with potentially, if we have time for it, the third item of the other mail Carsten sent in, and I don't find on my screen right now.
I also submitted.
But it's discriminated.
I also submitted some additional slides. So
yeah,
if we have
on
time
discriminated unions.
Yes.
Michael, do you want to start ahead on the general topic of the survey?
Sure. Sorry, just give me 1 second. Sorry, just every phone rang at the same time here. You know, I have a slide, so let me put it on if I can.
Yep.
Okay, so this is really the crux of what I'm thinking about, is that that this is something that I'd like to go on CBOR.io. I think, if you know, Carsten agrees, I don't think this is intended to be an RFC, but maybe we would want to draft part of it in the form of an internet draft. I'm not sure about that. I mean, we could go out and ask people with a survey or Google Docs, but I'm thinking just interview, asked to fill in template. So what's the purpose of this in my mind? My mind is that when I went through to pick some implementations a couple weeks ago to work with, I found that I really had to get, well, I'm going to say, very deeply into implementations. There's quite a few. Some languages have quite a few implementations, and they're really not all equivalent. So just to give the group an example, there's a Rust implementation which is based upon the Rust serialization and deserialization mechanism known as SERDI. And you'd think it would be great since it supports all sorts of other things like JSON and message packer and a whole bunch of other stuff. But it turns out it doesn't support tags. And then it turns out that in addition, it's really only suitable for serialization of structures that you've defined in Rust that you want to serialize to CBOR or something else, and then you want to serialize them back. So if you made a video game in Rust, let's say, and you wanted to make a save file, a self-describing save file, and then you're going to reload it later on, this would be a great thing because it would allow you to serialize any structure that you could define in Rust, but the results would be in some Rust-defined CBOR protocol, right? So if you tried to build a CDDL for it or something like this, you probably would find that it was unstable, but it's self-describing, so it would, I don't know what happens when you upgrade your game. I don't know if you wind up with free upgrades to your save files or not. But in any case, if your purpose was then to send the save file across the internet and reload it into a version written in C#, you're probably out of luck because it probably doesn't have any kind of stable facility. So that's the kind of thing that I would like to get into the survey. I've also been through a couple of C implementations because I actually have some C code and some Rust code that need to interoperate. Surprise, surprise. And so I kind of went down some of the same space again. So what I'm hoping to do is kind of describe these. I don't want to judge them because they have different purposes. But I think it's really important for us to understand, yeah, there's a lot of implementations out there, but in fact, in some cases, there's 6 implementations, none of which do what I think that many people in this working group would expect them to do, because they all cover a different part of the elephant, if you know the analogy. So I think that part of the things that part of the questions I intend to ask is, so for instance, like tags, for instance, does that, are they, is it intolerant of tags? Meaning they break, that sound would be bad. Optional, core tags only, that's probably the wrong word to use here. RFC 8949 tags only, user defined tags, and some implementations are tolerant, but they don't give you tags, but no user interaction. So you put whatever tags you like, but it doesn't do anything with them. It just skips them. How about no API interaction? So that's something that I think is very different among things. Another one is floating point, for instance. It can be supported, mandatory, optional, and then we have half versus full or double, I guess, support. So for instance, many embedded people, they might say, I have no use for floating point. I'd really like to be able to compile it out. And some libraries, this is not a problem. And some of them, if you don't use any floating point, well, then the code is arranged such that the linker probably doesn't include any. And others don't have that problem. You have to explicitly compile it out. So that's something I would like to get at. And then there's a lot of variability in decode. We obviously have pull parsers that people have described. Okay. We have SAX-like parsers where you get a callback per thing. And then we have ones that are like get next object. And then we have ones that roll your own, right? So they basically provide decoders for all the major types, and that's it. You should put it together yourself in your own code. And there's some good reasons to do each one, but that's there. I don't know how if to describe SAX parsers in a way to someone that doesn't know what SAX is. I don't know if someone has some ideas about that.
Well, they're usually called event type parsers.
Yeah, you're right. Okay. So that's my idea. And I would appreciate some feedback as to what direction here, and if I'm captured or if I explained it well enough to other people to so that you understand what I had in mind.
So I think that what excuse me, what you just said is a pretty convincing demonstration that we actually need to write that draft first. And that
Okay.
draft will simply define terms for these different categories of implementations. So you know that what the non-allocating parser is and what an allocating parser is, and you have DOM and event and pull type parsers and so on and so on. And then based on that draft, we can actually do a survey and ask people where do you put your implementation, or is your implementation maybe something that really requires modifying that draft once more.
Okay. So so basically we're gonna write the draft with the things, ask people to self-identify and tell us where we're missing critical bits there.
That's my proposal, yes.
Yeah, that sounds reasonable. The other thing I want to ask is I want to know what to do with implementations where where I don't get responses, or where like there are what appear to be sometimes active GitHub code repositories with pull requests that are, say, less than 6 months old, but no actual activity for more than that time. So in other words, there's people that would like to contribute to it, but they aren't able to. And that's I don't know what to do. Would we leave the results blank? Do we fill them in the best that we can think of? Do we ask somebody else that may be involved if they would like to fill them in? They may say, gee, maybe I should become the maintainer. I don't want to mark implementations dead when they're just, sleepy, or they've served their purpose or something, or there. Again, in the Rust space, there's a kind of, I've realized it's a closed pointer loop of please don't use this implementation, use that one. And you go around the loop and you realize that it's not going to work. You have to pick one of them, or you have to make your own, I guess. So I don't know what to do about that as far as from a political point of view. I want to be inclusive, but I also don't want to put inaccurate or dead information into this.
Well, I mean, oh, go ahead.
Hi, Jessica.
Okay, we can list them, and without putting, if we don't get any response, we can still list them and not list what features they have.
Yeah, so we kind of have that on CBOR.io already, right? We have a list of things, and we don't have we have a half paragraph. So we already kind of have that.
Yeah, I don't see a better solution. I mean, it's in the implementer's interest to answer this survey.
Yeah.
So I hope that it doesn't happen too often, that we don't get responses, but I don't think there's much more we can do, right?
For projects that have a public issue tracker, we could ask about data from them on that issue tracker, so that we at the same time reach the original author, but also reach other parties that are interested in keeping this alive and are possibly considering stepping up as maintainer or doing something about that.
So I'll post basically if I can't get I may just in many cases post an issue and to seek out the maintainer that way, and ask them if they could, this. One of the questions I have is, are you on the mailing list?
Great question. Good.
Right.
Yeah.
And if not, why? The other part is, you know, maybe they would say, well, I would love to have like a blog that I follow, or I would like to have a announce list, or I don't know what. So I think that's something I'm interested to ask them for that part.
And I think it's a valid question to ask how to format this. So survey like the Monkey one, or Google Doc, or yeah.
So I think I just put the template for the moment into the internet draft that we just proposed. And then I'm thinking that it's just a page. I'm thinking that it's really should be a page per implementation. That way they could actually even throw it in their source code if they want to.
Yeah,
and
but I think something more dynamic will get people to answer more.
Yeah.
If you have
Okay.
Google survey, or yeah. So
I don't know how to use those, but my
I
school board
believe
throws those
that
at me all the time.
the Secretariat could help us. We had a survey. We're starting to talk about surveys for the CDDL features work we did with Jim.
Yeah.
So I could find more info about that.
So one thing we could do is when we have this draft, we could use the GitHub repo for this draft and open the wiki feature and simply start creating a wiki page per implementation, and fill in our misunderstanding of what that implementation does, and then point the authors to that and say, if there's anything wrong, could you please do that? So if you need an answer on the internet, you first generate a wrong answer, and then you get the answer.
Yes, exactly. Okay. Which law is that? I can't remember.
Cunningham's law.
Thank you.
So we would simply make those.
I was gonna post the wrong answer and see if someone could correct me.
We would simply make those 75 pages from the ones that are on CBOR.io and start filling them in a little bit, maybe, based on what we actually know, and then wait for things to actually update those wikis.
Okay. So then probably just Markdown.
Yes, like GitHub wikis are.
Yeah. Okay. All right. I don't have anything else to say on this.
Already sounds like a good plan.
Will you start the terminology draft?
I will start the terminology draft.
Great.
Thank you. Any more comments on this topic? Ideas that we should consider now before things get actually started? Then I'd like to move over to the next topic of the agenda, that is packed CBOR. We've briefly talked about this in the last interim. Carsten, the floor is yours.
Right. You may want to use one screen per slide and not.
I'm trying. I'm not sure.
Anyway, not that important. I just hate it when things scroll uncontrollably in front of me. Okay, so this is an update on the CBOR pack discussion we have had at the end of October in the interim. So this took a full 3 months to ripen, but I think it actually is much more ripe now than it would have been if we had tried to do it faster. So I've submitted the Dasher 1 today Did anybody read that? Yep.
Yeah, halfway.
Good. Okay, so basically there was lots of editorial stuff that had to be fixed and terminology that needed to be defined and so on. But I think the most important change between 0.0 and 0.1 is that the draft now has a clear split between the unpacking operation, which is really the part that needs to be rock solid and standardized and be part of as many CBOR libraries as possible, and the table setup part that will always be a little bit more application specific, and we will have some application specific static dictionaries and all that stuff. So the intent with the current draft is to have a clear separation between those two. The other changes, which are in part quite significant, have to do with adding suffix packing. 0.0 only had prefix packing, item sharing, and prefix packing. So we now have added suffix packing and are calling the whole thing affix packing if we don't care whether it's prefix or suffix. And the other thing is that both for suffix and for prefix packing, we specify how to apply them to containers. So in 0.0, it was only for strings, and it now also covers arrays and maps. So this is the other big construction side, which is kind of orthogonal to the split thing. So they are not really influencing each other very much. So the 0.0 started with defining what a packed CBOR data item is, and 1 simply defines one of potentially many future table setup tags, which are called basic packed CBOR. And there's also some text which probably needs to be expanded a lot about application specific and explicitly tagged additional setup. So this is not meant to be the one and only tag, and that's why it moved to 1+1 space also, but it's the one that people can start with if they don't have application specific requirements that would make you want to do something different. So that's an overview. Next slide. So adding suffix packing is well, kind of obvious what you need to do, but doing this in a naive way would mean that we allocate the same number of tags we have allocated for the prefix part for the suffix part, and that creates a little bit of cognitive dissonance for me. And my hunch is that prefix packing is actually way more important than suffix packing, and I'm really looking forward to be corrected on this. So I know that you will have .html suffixes and something like that, but maybe that's not really the main purpose of the CBOR packing. So maybe we want to allocate more of our tag space to the prefix part than to the suffix part. The disadvantage of doing that is that the arithmetic for doing the various tag ranges and so on becomes different between prefix and suffix packing, but that's maybe a small price to pay. And since we are really unlikely to allocate more than one 1+0 tag for this, we already have to decide where that goes, and assuming that it goes into the prefix case, that will already define a difference between prefix and suffix packing. So there are lots of not so interesting but detailed and in the end probably important decisions that have to be made here. And I'd rather do those based on a corpus than based on hunches. So creating a corpus of CBOR data items that we want to work well with CBOR packing is probably an important next step. So if there are no direct comments on this, let's go to the container affixes. Strings are a lot like arrays, so it's pretty much obvious what you do for arrays. But if you want to provide container affixes for maps, well, the first observation is that maps are unordered. So prefix and suffix packing are actually the same thing for maps. And the second question is, how do we handle keys that turn up both in the affix and in the rump, in the thing that is in the packed structure that says what other things need to be in the combined map than what's already in the affix. And we could simply forbid that, which I think would be a missed opportunity. Or what -1 proposes is to have an override feature here. And that's actually a place where prefix and suffix packing could differ. And we could use the bit that is available here between prefix and suffix packing. And we could say that one of them, the rump overrides the affix, and in the other one, the affix overrides the rump. So the bit distinguishing prefix and suffix is kind of attractive, and this tries to give it a good use. And I think both will find use in practice. So it's probably a good idea to have both. What the current proposal doesn't have is a way to remove entries, because that would open another can of worms, and I tried to keep that can closed.
Brief question on having both cases. Why would one ever have a case where the suffix should override the rump rather than not having the data item in the rump in the first place?
Because the rump may actually be constructed from other things that in turn are shared items and so on. So if you have a rump that is entirely spelled out, that would be weird. But given that the rump may itself be something that has references to shared items and even maybe to other affix compression, it's probably a good idea to be able to override things that are in the rump.
I see. It will just need some very careful spelling out, because that's definitely not obvious.
Yeah.
Imagine you had a CBOR protocol that was processed through a series of steps. It starts off really well compressed, and then things get changed in the data in the rump, and at some point it turns out the compression provides no value whatsoever, and that's unfortunate. But it was cheaper to do that than bother fixing the rest of it or figuring it out. I mean, you could remove all the compression, but you still don't know, because you haven't gone completely into you haven't descended through all the parts of the data, right? You've just edited some of it, and as each part gets edited, some compressed pieces get removed.
This does bring up memories of FBI documents that have PDFs that are blacked out selectively, and yeah.
Yeah, no removal at the current point in time. Yeah, so again, this would be one place where the prefix variant is the more likely you will be using, and the suffix is really not that likely. But I still think it's useful to have the affix overrides rump case as well. But let's verify this from the corpus. If we can't find a good example for that, then maybe we don't need to support that use case. Any other questions on container affixes? Yeah, so this is the slide that I used the last time, which essentially says how many prefix references we have of which kind. So it's 32 plus 4096 plus a number that I have no idea where it came from. It's probably 2 to the 18 or something like that. I have to look it up again. Yeah, that needs some more thinking, but I thought before I put energy into that thinking, I should have a corpus to look at. So that's just a reminder from last time. Next slide. So going to the table setup, again, I hope that the actual packing can get stable relatively soon. And the table setup one we want to do should be simple, and we should keep in mind that there will be application-specific versions of that. We need to provide a framework for the table setup because, yeah, otherwise the actual unpackers will need to be very different for each of those. So we should give some guidance for how this table setup stuff works. So basically what I'm proposing here is that in a CBOR structure, for every data item in there, so the total data item and all the subtrees, there is a table setup that applies to that data item. And normally it just inherits through the tree. And the default table setup, of course, is 3 empty tables. Actually, if there is any reason to put something there that is really useful for any kind of CBOR, then we could do it in the default, put it into the default table. But I didn't find anything for that. But maybe, again, that's just lack of imagination. So there is a default table setup. And then I expect that different application environments will define different table setups that are applied to the root of the data items defined by the media types for that application environment. So just like we in zip compression, we had this zip static dictionary, we would have a static dictionary for a specific application. So that's one thing, or it would be the table would be overridden or augmented by tags that are in the structure, and the previous version just had such a tag at the root. And I'm proposing to open this up and say it could be anywhere, but that's maybe only something that you allow if there is if the CBOR data item is likely to be the result of some composition. So normally you would still have just a single tag at the root. And the document provides one of those, the basic packed CBOR, which essentially provides a way to include 3 enclosed tables that will be prepended to the tables that already apply to it. So if the media type says you have these 5 keywords, you would be able to put in another set of keywords, and that would be prepended. So it would get the better places. And yeah, there is some there are some ideas how to do this differently, but the basic approach and the one used by this basic packed CBOR would be to always prepend them, because the specific document, specific data item knows better how to use these than the static dictionary provided to it. So given that this is just prepending things, everything else moves up the numbering space and potentially gets longer tags and longer reference. So you would, in a static dictionary, try to sort things by frequency, but that's already the natural way of doing a static dictionary. So that's not really a big surprise here. So one thing we did, next slide, one thing we did discuss last time was that actually there are not increasingly worse positions in that number space, but we have different buckets. So the first 16 numbers are actually all the same, and then the next 48 are all the same, and the next 512 are all the same, and so on. So maybe there is a good reason to actually use this structure to define alternative insertion points. So you don't necessarily insert at the start, maybe you insert into the next bucket. So I didn't write anything in the document how this could be done, because that would be the job of the specific tags to do that. But it's an idea that probably should be said, so when people implement this, they know that tags might be defined that do that. Okay, so that's the bucket idea. Next slide. What I would like to do next is look at this O1 draft, answer the issues that are in there, and generate a -02, and then see whether we actually can use that already, or whether we need to cook it some more. So my hope would be that we can cook this without completing the definition of all application-specific tags that we will ever need to define for packing. So people can start defining their application-specific tags a little bit later. But we probably should already discuss the usage of packing in the specific application environments. So for instance, for the suit people, we would see how would that have been used in the suit environment. Unfortunately, they had to define their own little application-specific scheme for this, because we were too late with this. But in other application environments that need this, we would also start discussion about how would we apply this here. Is this something that you even want to have in that application environment? And if yes, how would you make use of that, and what application-specific setup tags would you define beyond the basic packed CBOR? And how would you define your static dictionary if something like that can be defined? Yeah, that's it.
Thank you, Karsten. Very good and thorough presentation. I agree with your hunch that prefixes are more likely to be common and important than suffixes, and also the run length of prefixes is likely to be quite a lot longer than suffixes, as they're pieces of URIs, for instance, often.
Thank you.
I have some questions, Karsten, about your, I guess, 2.2 and 2.3 table.
Yes. These haven't really been updated yet, so yes, go ahead.
Michael?
So I was trying this press spacebar to talk, and I guess I didn't do it right. So in table 1, there's a negative integer n,
Yes.
and I guess that's a tag applied to a negative number. And of course we have, and I don't understand, for n larger than 8, it gives us a negative element number, and I don't know what that means based on the example and stuff.
No, because the integer n is negative. The result is always positive.
Oh, of course. All right, that makes more sense. Okay. So
There should be some examples there.
Yeah, so doesn't that overlap with the positive numbers then?
No.
Because they're alternating positive,
Yes.
negative, positive, negative. Okay, I understand that.
So this is the zigzag encoding that Google pioneered in protobuf.
Right. All right, great. Okay. The second question I don't understand is in the table 2, the suffix reference. Okay. So there's a TBD. So I'm not understand. I guess that I'm trying to understand how that works, and I also don't understand why tag 6 suffix has element number 0 and nothing else. I guess I'm not comprehending how that fits in. Yes, exactly. Thank you for putting that up. Like tag 6 is special in the thing, in the encoding, but why? What is it tagging?
It's tagging the rump, actually. So if you have something that you really use a lot, then you have a 1 byte referent that you can use around a rump to reference suffix, prefix value 0.
Oh, I see. So you basically put this on the, okay, you tag the rest of your data, and that becomes the, okay, I understand now. The text tried to do that, but I didn't get that. We'll need an example.
Yeah.
Also, a review, a more precise review will be really, really good for improving the text.
Yeah.
Yes.
Yeah. So
if you can see what was not clear or what was missing.
I agree. Yes. I feel I also have some confusion about the encoding, and this refers to the 2.2 referencing shared items. So we have a simples value 0 to 15, and yet 24 is usually an important number in CBOR. Is that because we've just omitted 8 numbers, or is there some other thing I don't get about the encoding?
So for the first 16 element numbers, you have a simple value. So you have a single byte encoding. For the next 48 element numbers, you have tag 6 and a single byte integer. So from -24 to +23, if you plug these numbers into the formula that is there, you get the element number 16 to 63.
How do I know that element numbers 0 through 15, they say simple value 0 to 15? So that means like that, would that normally be an integer then?
Well, the encoding is a simple value. And that encodes an integer, which is an unsigned integer, which is the index in the shared item array. So the whole point of the table is to map the element number space, which is the set of unsigned integers, to map that into efficient ways of encoding it in CBOR. And for the first 16, we can just allocate half of the simple value space. And for the next 48, we can use the single byte numbers plus a tag around those. So we have a 2-byte encoding. And then, of course, we have a 3-byte encoding for the next 512 and so on and so on. Actually, it's not 512, it's 448 or something. Yeah, so we need a few examples. I completely agree with that.
Okay, I forgot that the simple values was not what was that part, and that there's a bunch of unencoded. So that's major type 7, right? So that's what I forgot, that it was called, that there were floating point numbers and simple values. And so we had a 4 bits of unallocated space there. Okay.
That already sets a few good action points on the topic of what to talk about next. Is there, I mean, discriminated unions are still on the list. Do you think that there is much more to be gained from continuing this discussion? Because otherwise, I'd suggest we move on to the discriminated unions.
Well, I'll take all feedback I can get for this. My plan is to have a next version of this draft pretty quickly. So please keep those pull requests coming. Then maybe it should be easier to read, and we can circulate it a little bit more widely, so people can application developers can start commenting on it and so on.
Yeah.
So Michael, I wrote down for you to possibly review the document or send comments in the mailing list if you have time, since you already had some.
Yeah, I'll try to recap them, but
yeah,
I'll have I would have to be figuring out how to write the code.
But maybe that's next step, I would say.
Yeah.
That's actually one other important next step. I should be cleaning up my implementation and putting that somewhere.
That would be very much appreciated, yes.
The problem with implementing this, of course, is that there are a million ways to do this. And I probably just do a really stupid compressor. So it's easier to see what the standardized parts of this are.
Yeah, but then again, that's something that we could still improve and improve later on. And
well, that's really something where people can pour infinite amounts of secret sauce over the thing, because we don't have to standardize the compressor. We're standardizing the decompressor. Good.
Yeah, let's good. Let's move on to discriminated unions. I hope my browser survives this. And still Carsten.
Yeah, so this is one of the items that came in from implementers, and actually it's a good example of the usage of CBOR in a language environment. So just as Michael, you mentioned 30 in Rust, there are other people who are using CBOR for their language runtime support. And many language environments actually need something like this. And traditionally, they all have defined their own things. So Python has Pickle, and Perl and Ruby have marshalling, and everybody has their own thing. And at some point, for instance, the Haskell people decided they don't really need to invent another one of those. So they went for CBOR. And they came back and said, oh, we have this need for discriminated unions. So they actually came a while ago. They needed a time tag, and this is what turned into tag 1001. And we already have tag 27, which was motivated by Perl and so on. So that's going to be a subgenre of CBOR tag development, making sure that language environments can do something useful with CBOR. So this is not coming from the protocol development side, but from the language environment side. Next slide. So the specific gap that was identified here was that on one hand, it's really easy to express a union type in CBOR, because CBOR is a schemaless encoding. So if you need a union, well, you just put whatever you want to put there into your data item, and you're done. So the CBOR doesn't need any support for unions. But the problem is this only covers actual unions where the values of the contributing types all are on their own, standalone, meaningful values of the union type. But sometimes you don't have that. So you need numbers somewhere, but you need to say whether that number is actually a house number or a post office box number. And in that case, just writing some address component can be a house number or a post office box number doesn't help you. You need to be able to discriminate the various branches, the various alternatives of that union. That's where discriminators come in. If we actually write protocols, then we usually define labels for those discriminators. So we often set up maps and discriminate the various cases by having different labels. But that's not necessarily what we would find in a programming language. And what we have on slide 4 here is an example from a programming language, and I think that's Haskell actually. I haven't checked that, but it looks very much like Haskell. So here we have a type called expr, and this actually is a discriminated union with 6 branches, and the terms lit, add, subneg, mal, div are actually the discriminators. So they identify which of the choices are actually taken. And the things behind that, the int, expr, and so on, these are the content of the discriminated units. So that's the data that come with that specific choice. So that's what the Haskell compiler would see as input. And next slide. The Haskell compiler really would like to translate this into something like this, where you have discriminators that look like tags, which are put on the actual parameters for that specific alternative. So you would have tag 0 for the lit case, and tag 1 for the add case, and so on. So there is no point in carrying lit and add and so on as strings, because this is all done by a compiler which knows what's going on here. So we're not going to do the JSON thing here. Actually, yeah, we really would like to have integers here in a tag-like construct. And if this looks familiar after looking at CBOR PEG, yes, this is kind of familiar, but it's a very different application. So of course, if we ever come into a situation where we would define a protocol, we would probably define tags for addition, subtraction, and so on. But again, this is a compiler. The compiler doesn't want to reach out to IANA and register these tags. The compiler just wants a pool of tags it can use. Next slide. So what the compiler really wants to generate is something like this. And that requires some predefined tags that can be used. And the current proposal is to register 7 1+1 tags, because that's really the vast majority of all discriminated unions have 7 or less choices. And then 2048 1+2 tags, and then a catch-all that will provide anything up to 64-bit tag numbers. So this is all written up in this not yet submitted draft that is on GitHub right now. And if you are interested in this subject, please have a look. So I have some co-authors with whom I want to finish the text of this and submit this in the next couple of weeks, so we can see whether the working group is interested in taking on this tag, or whether this should be something that is an individual submission or just goes into the registry and so on. That's what I would like to figure out.
Just for a brief preliminary gauging, has anyone read the pre-draft yet?
Well, this is the first time I have shown it to anyone, so I would be surprised.
Okay.
But sometimes people look at my GitHub repository and find interesting things there, but
Basically, it would have been from
are following you on GitHub, and then they get this notification cool stuff. But yes, I saw it fly by. I was like, "Oh, unit's cool," and that's done.
Okay. But please have a look so that we could have more informed, a bit more for discussion next time, because we're running out of time today anyway for any more discussion. So I think we should go right to any other business parts. Anything anyone wants to bring up?
So before we close, I just wanted to thank Barry for all his work as AD, and I'm looking forward to I hope I can do a good job as your following AD. But thank you so much, Barry.
thank you.
And thanks from me too. Also to you for giving me the introductions and kind of getting me in here. I think that's it for today. We'll reconvene in 2 weeks. Minutes will be posted. Recordings should be up around next week. Thank you all for your input and everything you've prepared. And see you then.
Thank you.
Bye-bye.
Bye.